Welcome to today's presentation, SQL Server 2012 Always On. Intellinet is a management consulting and Microsoft-centric technology services firm. We help executives succeed by providing strategy, process, and business technology services with measurable bottom-line results. Intellinet is a Microsoft Gold Certified partner, and our experts are top in their field. We have lived up to our motto of promises kept in serving over 800 enterprise clients worldwide since 1993. Today's speaker is Intellinet Principal Consultant and 8-time Microsoft MVP, Jeff Hyten. Jeff has over 20 years of experience as a Microsoft SQL Server professional specializing in high availability and high performance systems. Jeff was recently appointed as an Interim Director of Professional Association for SQL Server. Jeff?
Thank you, Laura. Well, let's talk about the SQL Server 2012 Always On. If I slip up and say SQL Denali, it's out of habit. We've only gotten the name now for about a week. So what is this Always On thing? A friend of mine, when we first found out about this, he goes, well, what's with this? Every SQL Server I work with is always on. Duh. Well, Aaron has a succinct way of putting things, but the whole point of Always On is sometimes your servers aren't on, despite the fact that you would desire them to stay on. What Always On really is simply a new branding for all of the SQL Server high availability and disaster recovery infrastructure technologies. We used to call this Project Hadron, but after an unfortunate series of typographic errors, that name just didn't work anymore, so they came up with this Always On branding. It's really two pieces that go into Always On. First of all, we have two core technologies in there. There's SQL Server failover clustering. This is the same clustering that you've seen for the past several years since version 7.0. And SQL Server database mirroring, but with a lot more manageability and control pieces on top of it. And we have two elements that these are built into. We still have SQL Server failover clustering, same name, and a new feature called SQL Server availability groups. Most of this presentation is going to be focused on the new capabilities of availability groups, but we are going to talk a little bit about the improvements in failover clustering. Before we really go into the details of the technology, we really need to define some terminology. We need to talk about high availability versus disaster recovery. We use similar technologies and techniques for each, and some of the same metrics, but there's a very big difference in approach. High availability generally is about resolving a single point of failure in your system. Your recovery point objective, that is how much data you're allowed to lose during a failure, is almost always zero, with the caveat that any transaction that's actually in flight gets rolled back and could be retried by your application logic. And your recovery time objective is usually less than 1 minute, sometimes in the matter of 10 or 15 seconds. Basically, 1 or 2 retries from a rather impatient web user is about all that you're going to be able to tolerate on this. Now, we have the same type of metrics when it comes to disaster recovery, but this is some type of a major failure. You've lost your data center. You've lost a city through an earthquake or fire or flood or tornado event, something really bad, and you have to move to a completely different location. In this case, your recovery point objective is usually greater than 0. It can be a matter of a few minutes or a few hours, depending on the technology that you use. And your recovery time objective is usually 4 hours to several days, again, depending on the technology choices and the preparation that you've made for this. So what can this Always On thing really do? Well, here's a brief list of some of the pieces that you get with each. With failover clustering, we have multiple servers, just like we've always had, and multiple instances. A new feature in failover clustering is the ability to do multi-site clusters. Up until now, you've had to do a VLAN or virtual LAN so that all elements in the cluster had the same segment of IP addresses. With Windows Server 2008, the underlying clustering technology improved, so that's no longer necessary. With SQL 2012, you get the same capability at the SQL level. We also have some more robust failure detection options. We'll go into that when I detail clustering a little bit more. Now, the always on availability groups, this is the new stuff. This is the really cool stuff. I like to call it mirroring plus plus. The terminology mirroring is going away because we now have multiple replicas. Instead of one system and a mirror, we have the ability to create multiple copies. At this point in the technology timeline, we're able to create up to 2 synchronous and 2 asynchronous replicas. We also have the ability to group databases together for failover. Before, mirroring was strictly a single database technology. That made it very hard to do things like SharePoint, where you have multiple databases that depend on all of them being under the same name, same location, same place you can connect them. The way they do this is they actually wrap mirroring with a clustering control. This gives us the ability to do an abstract name so that we can still connect to this set of databases using the same name no matter where they actually reside. And finally, in order to make this more accessible to a database administrator without needing a Windows system administrator to do all this, the setup of the availability groups is included in the SQL Server Management Studio application. Let's look at clustering in detail. This really is your father's clustering, only a lot better. Just like now, clustering begins at install time. You create the first node, and that is a functioning cluster system when you've completed. And then you simply run the installer with a different mode and add additional nodes to it. So it's node by node install, node by node upgrades. You still manage this with a Windows Server Failover Cluster Manager, which means you need system admin rights on your SQL servers. You have a single copy of the data, which sometimes is good, sometimes is bad. If you have a very large data set, the cost of keeping extra copies of it may be prohibitive. And of course, the failover unit is the instance. That way we get all of the linked servers, all of the jobs, all of the elements that are with a SQL Server instance. Again, the improvements we see in this version are the multiple subnets, so that we have the feature set aligned with Windows Server failover clustering, and the more robust SQL Server, or more robust SQL instance failure detection and management. This failure detection, up until now, was a very simple system. We had a looks alive and is alive, or what they'd call a basic and a robust check. The looks alive was simply, is the service down, which is still one of the levels of failure action that we get with the new health check. The other one was the server unresponsive, which was basically running a simple query. In the previous versions, it was select at version, and getting some answer back from the SQL engine just to see that it's responsive. Now we have a new element called SP Server Diagnostics. It's a stored procedure, runs in the master database, and it actually responds to you. You can give it parameters to say, I want to know, is the service down, is it unresponsive? I also have 3 different errors. I have critical, moderate, and qualified error. Qualified is actually an error that you could raise inside a query processing to say, wait a minute, I haven't got all the resources. Maybe I'm working on a set of data that is old. Maybe the updates haven't been posted for a BI system, something, and I want to fail to a different system that has a more up-to-date copy of the data. And of course, each action, if I set a 5, that means a 4, 3, 2, or 1 would trip the failure over to another cluster node. Our default is level 3, which is actually a little bit better than we saw before. Before, we only had 1 and 2 were our tests. Now we actually see, is the system running, and is the system running correctly? Before, these types of failures where SQL was still responsive but not operating correctly would be kind of hidden. You wouldn't see them at all. And of course, we actually have a 6th level. We can turn it off for maintenance mode so that we can operate on the system without breaking it, without triggering an inadvertent cluster failover. All right, let's talk about availability groups. Again, before we talk about something, we need to talk about the vocabulary. What are the new terms? Microsoft always comes up with new terms for new technologies. We have 3 terms that we need to understand here. First of all is the availability group itself. This is simply a group of databases operating together for failover capabilities. Availability replica. This is a copy of that set of databases operating on another machine somewhere. And finally, we have an availability group listener. For those that are familiar with clustering, this is a virtual network name object. It appears in the clustering resource. It shows up in Active Directory as a virtual computer name. It also shows up in DNS, and that's how we can reroute connections to it. Everybody connects to the same name all the time, but under the covers, DNS will update that to the correct IP address of the replica that is live at the moment. Let's see a little bit about how this works. Those of us who remember the old Reese's ads, what's your peanut butter doing in my chocolate? What's your chocolate doing in my peanut butter? Well, this is clustering in my mirroring, or vice versa. Now, everybody thinks of clustering as this shared storage management system, but that's only one of two pieces that clustering does. Clustering is really a distributed failure management framework. Among the set of computers operating the cluster and potentially an additional computer, you have the ability to detect which ones are operating and which ones are not. And this is the feature that they're leveraging to manage availability groups. And this is the same type of clustering management that we see with Exchange, with the new data availability groups. It's used for Hyper-V, for Windows native services like DHCP and file sharing, and of course the basic SQL clustering. Microsoft has had better than 10 years to refine and perfect this particular technology. Rather than reinventing the wheel like they did with SQL 08 and the witness server for mirroring, this is, or SQL 05 and 08 with the witness server, this is leveraging a well-proven and well-tested technology. They still use mirroring to create and populate the database replicas. This means that every server has a local copy of the data. There's no single shared copy that has to be synchronized. This means you don't need a SAN to implement availability groups. This can be done with local direct attached storage. So clustering gives us this failure management, this name abstraction, and the resource grouping. All native clustering features, nothing new, nothing magic about that. So what really is a replica, though? You heard me use this term, but what really is it? It's not just a mirrored copy of the data. First thing we can do is we can use it as an HA or DR, high availability disaster recovery data set. Now, if we're set up on a synchronous mode, we can do an automatic failover to this other, to another one of our synchronous replicas. If we're asynchronous, this has to be a manual failover. This goes with Microsoft policy. They're not going to build a system that automatically loses you data. If you're in an event that needs a manual failover, you're going to have a human involved in there. This is generally the disaster recovery side of the HADR environment. At this point, you choose that, yes, I can lose a little bit of data in order to bring up an entirely different and far distant data center. I can use this for backups. I can offload work to it. I can pull full or log backups. I can do differential backups. There's some complicated pieces in there that has to do with the synchronization capability, or whether the replica stays in sync during the process of the backup. But log backups work in that they actually notify the primary that there's a log backup taken, so everything is put together and is visible in the normal system databases, so your log chain is still visible to Management Studio and everything else. Finally, I have a read-only replica. Now, this is a new feature. This is pretty cool. Just like when SQL 2005 came out with mirroring in the first place, in order to use it in an automatic fashion, they modified ADO connection properties and gave you the ability to put in two servers, the primary and the mirror. So it would try the primary, and if it couldn't get to that, it would go to the mirror. Well, read-only adds another property in there. It says, I have read-only intent to connect to this availability group listener. When I connect, it doesn't connect me to the live replica. It goes and connects me to the live primary read-write version. It connects me to one of the other replicas. Now, that replica has to be in sync, has to be up to date, has to be live, and you can choose what the order of these are going to be, what the priority connection is. What's nice is if I have to fail over to one of those other replicas, the read-only connections go back to my primary or to a separate replica. So I'm able to offload read-only workloads onto a separate set of data automatically and transparently. It's not just that I point to that server, I point to the abstract name, and the read-only connections get redirected just like the primary connections do. Now, you didn't think this was going to be without a couple of catches in there, did you? It always is something, that you have to do, always some limitations in there. First thing, every availability group name must be unique on the Windows Server failover cluster, and for that matter, in the domain. You treat an availability group like it was a computer. for that purposes. Again, it pops up in Active Directory. It pops up in DNS. So for the next one is for a given availability group, all your replicas must be hosted by server instances on the same cluster. Well, that kind of makes sense. What cluster is the unit for managing failover? So a single cluster has to manage all of the replicas. Now, from a practical standpoint, they did not put an upper limit on the number of availability groups on a server. But for most commodity hardware systems, the dual socket, quad socket systems, you wouldn't really want to go above about 10 availability groups per instance. Same thing with databases in an availability group. Maximum of 100 is the recommendation. And considering most SharePoint instances, most SharePoint farms really don't go over 100 unless they're extremely large, that's probably a workable limitation for just about everybody. Now, there's one really hard limitation to describe. I'm going to go ahead and show you what Microsoft says about it. And if you create an availability group on a SQL Server failover cluster instance, oh yeah, did I mention you can combine clustering and availability groups together? So an availability group can actually be hosted on a clustered instance of SQL Server. In that case, the clustered instance becomes the automatic failover, and all of the availability groups go to a manual failover capability. But anyway, if you're doing this in a cluster, you cannot host the failover partner on the same node that hosts the primary replica. It's actually a lot easier to show this with a picture. So what you get is, if I have a cluster showing here with 3 servers, 2 instances, if I have the instances on separate nodes and put an availability group across multiple databases, that's good. If I fail that second instance onto the same physical server that's hosting the first instance and that's still an availability group, that's not supported. That's not going to work. Don't try that. I call that a folded topology, where you're kind of folding everything back onto one server. It's simply not going to happen, and you need to modify your cluster capabilities so those don't go together at any time. All right, now that we've talked about it, let's see how this stuff really works. I've got a demonstration laboratory set up here showing 3 SQL servers, a SharePoint server, an AD controller. This is kind of the data path that you would see for something like that. It's not very complicated. Just simply follow the blue ball. Okay. Seriously, the lab looks something like this. On the left, we have the first subnet with SQL 1 and SQL 2. This represents 2 independent units on the same location, in the same data center, as it were, with an automatic failover capability between them. Obviously, since it's a lab, I have an AD controller that's also doing DNS, DHCP, and routing. I might as well get some use out of the box. The second subnet is truly a different subnet. It is a routed configuration. This represents a data center in a distant location. And finally, sitting on top of everything is the workload we all love to hate, SharePoint. Let me give me a second to finish. I'll stop sharing this. I'll start sharing my virtualized environment here. It's going to take a second for this to come up. There we go. Okay. This is SQL Server. At this point, it's still called Denali because I'm still working on Denali CTP 3. You can see here I have a couple of databases, SharePoint admin content and the SharePoint config. This is just a bare bones SharePoint application, but you could have as many databases in there as you like. And under management, we have this new availability groups. I've seen one of the later builds of this at the PASS Summit recently, and availability groups actually moves up to a top level under the databases, security, server objects, etc. So we started seeing all the AlwaysOn features as their own piece instead of being under manageability. Now, under this, I have created a availability group called Denali 3 AG1 GP. Okay, it doesn't like that. And in that, I have 3 replicas. I have SQL 1, SQL 2, and SQL 3. 1 is now the primary, so that's where everybody's connecting to. Under that, I have listed the databases. Notice I have a database up here called dummy that is not part of the availability group. I can hold extra databases or databases in other availability groups on the same SQL Server instance. So this kind of highlights the fact that my failover is a set of databases, not the entire instance. And then finally, I create a listener here. This listener matches up to an object in my Active Directory computers container. So if I look and create a new query on this, you can see my connections. Running a little slow because I've got 5 VMs running all on the same laptop here. No, not select, it's just next. I don't know better than that. All right, so you can see here what I've got, and you can see my, scroll down here below 50, you can see these are all SharePoint connections. Denali 3, SP1 for SharePoint. Let's start off, we can show you that SharePoint central admin site is running. Yay! All right. If I go back to SQL, and we can also show that it's running on the local subnet with an IP address of 10.97.230.52. Just to show you, this is all legit. Now, if I go back over to SQL 1 and look at my dashboard, by the way, this is part of the whole management studio controlling everything. You can see here from the primary, I can see all of my replicas, everything's synchronized, everything's up to date, everything's happy and healthy. Unlike clustering, I get a different view of availability groups depending on whether I'm connecting to primary or secondary. If I connect to my secondary over here, notice that number 3, it has a little red dot there. It doesn't know what's going on with 3. The rest of it's pretty much the same. If I bring up my dashboard, you'll see here it shows quite a bit less. It doesn't show all of the connections to everybody. Only primary knows everybody. It knows itself, but it doesn't really know about the 3rd connection. That's only the primary that handles that at this point. If I look at my availability group listener properties, this is still consistent. Notice at this point I have 2 IP addresses associated. This may be hard to see because it's faint, but it says 10.97.230.52 or 10.97.232.51. So let's go ahead and move everything over right quick. Let's go ahead. You can only pull this stuff, by the way, if you're running from the primary. I'll show you that. I don't have the option to failover. I can't make it go anywhere. There's no failover option here. But if you think of this as like a piece of string, I can fail over the replicas. I should be able to fail over. There we go. I can fail over the replica to 2. I'm connected to 2. I'm saying I want to take over. And yes, I want you to do this. It takes a few seconds to run everything across. Obviously, in a real infrastructure, this is going to go a little bit faster. Now, if I refresh my SharePoint Central admin, it's going to take a moment because it's querying into a new server. Same IP address because we moved the virtual IP just like we do with a cluster. Okay, we have an error because it's still not online yet. That's good. That's actually what we want to see. And now we have central admin back. Yet, if I go over here to Just going to go over here and bring up my cluster admin for a second, show you what that looks like. Now, I'm not actually going to change anything here. I'm just going to, there's my group. And you'll see everything is online on the current owner of Denali 3 SQL 2. Take a second, we'll see everything. Just let that live in the background for a while. Again, one overloaded demo later, it all works. All right. So we've got a local failover capability. What happens if we want a remote failover capability? Notice I'm only seeing a part of the puzzle here. I've gone over to 3. 3 doesn't know about, well, I haven't refreshed this actually. If I refresh this, it'll look up the new topology and see that 2 is the primary, 1 is the first secondary. Still with automatic failover capability because it's all up and running. Okay. Really didn't like that, did it? And I managed to lock up that. Okay, let's go over to, well, we can do this from 3. We don't have to look at 2 or 1. We got Management Studio here. There we go. All right, well, looks like we've locked up Denali. Looks like we've locked up number 1, which is cool. This is a highly available infrastructure. I'm just going to hit the power button on it and recycle it. Back over to 3 now that it's coming up. We'll let that come back up in the background. Oh, and if we go to SharePoint, we'll see SharePoint still working. I hit the refresh and I still get the central admin site. We're still operating, even though in the background it's a little bit confused and frustrating. It's still there. Who's got anything going? So I have Management Studio on 2. We'll go ahead and connect that way. Actually, I just want to connect to 3 at the moment. Because what I want to do is try to get a failover to 3 and see if we can get there. All right. We're looking good. Let's crank out availability groups. Connecting up. Now remember, even though I'm on the console of 2, I'm actually connected to 3 through Management Studio. I can take my replicas and go, I want to fail over to 3. Now this is where the really fun stuff. This is something we couldn't do in any previous version of SQL Server. I'm going to go over here to, actually, over here to 3 and watch this happen. But I'm going to do it, I want to bring up our cluster again. I want you to see what's happening here. Now, what you should be seeing here is the resources going offline and back online on the new nodes. There There he is. He's showing his online on 3. We look at SharePoint. Now remember the earlier IP address. Same name. I haven't typed flush DNS or anything else. All I've done is said ping this new one. And now the IP address is automatically changed. 1097.232.51. So it's redirected that name resource to a server hosted in another data center. And if I hit refresh on my central admin, I get the error, which is what I expected. It's going to give me the error the first time and then right back. Now I'm running SharePoint on a completely different server in a completely different data center. The only thing my user had to do to get it to work was to hit refresh, maybe twice. So you can see here, this is something we couldn't do with clustering. We couldn't do with any of the previous mirroring pieces without a huge lash up to fix things. Manual involvement on all this. At this point, it's simply a matter of failover from the operator side and from the end user side. Simply click retry. Doesn't get much better than that. No SAN involvement, no shared storage, and the setup is all through Management Studio. So I hope you've gotten a good idea of what the SQL Server 2012 always-on features can do for your infrastructure. This is, I believe, a real game changer. It's going to make high availability and disaster recovery available at not only a lower price point, but a lower infrastructure complexity point than we've ever seen in any previous version of Windows or SQL Server. Thank you very much.